In this lecture, we're going to present an overview of Python's exception handling mechanism. Conceptually, Python's exception handling mechanism is very similar to Java. So it's using a try-catch mechanism, although it's using slightly different syntax. So you begin with the try keyword, and you put your protected code that you want to execute there. This is code that you expect could cause an error, code that could cause an error. Next, you use except. You may remember that in Java it was catch, but here it's except, and then you give the exception name, which is going to be a class. So in Python, you're always catching instances of exception classes. So this is exception name 1 as E1, so that allows you to name the parameter and to process that particular object, so error handling code. And you could also, you don't have to bind it, so I could say cat except exception name 2, but this time I'm not going to bind it to anything, and I could have my error handling code. And then you can have an unconditional except at the end, which is going to catch any error. You cannot bind it because you don't know what exception you're getting. So it's simply unconditional error handling code. And you may or may not want to re-raise the exception in this case. So raise re-raises the exception. Then we have else, and this is code to execute if the try completes successfully, and it's non-protected code. So code to execute if the try completes successfully. Whoops. So if it completes successfully, I'm just going to, I didn't mean to cross that out, so I'm going to re-emphasize it. So this is code that is not protected. And we do not expect it to cause an exception. So we do not expect it to cause an exception. If it does create an exception, then we just want it passed up to an outer try block that can handle it, or else we just want the program to finish execution. And then the finally clause is like in Java, it's code executed regardless of what happens. So it's code executed regardless of what happens. So it's executed if the try succeeds. So the try could succeed and we will execute it. We could have an exception and handle it. Or we could have an unhandled exception. In all three cases, the finally clause will be executed. So for example, we may use this to close a file, making sure that no matter what happens, the file is closed before we leave this particular clause. So it helps to look at a few examples, and the first one we're going to look at is going to be one that simply iterates until we get a valid integer from the user. So while true, and you notice we embedded the try statement inside the while. And we're prompting the user to enter X, and then we take that input, which is a string, and we are passing it to the int function to convert it. So if it succeeds, we break out of the while and we print out the value of X. If it fails, then we catch it via a value error, and you notice we haven't bound it to any object because we're just printing, oops, not an integer, please try again. And you'll notice that since the try statement is inside the while, once we've handled the except, the loop comes around. Even though we exit the try, we go back up to the beginning of the while loop, and the try will get executed again. So if we actually run this, you'll see enter X, I'll enter Brad, oops, not an integer, Joe, still not an integer, 10, it is, it prints. Now what I'm going to do is instead of just printing oops, not an integer, I'm going to print, I'm actually going to bind it, so as V, and I'm going to print out args0. Now what is this, you might think? Well, it turns out that when every exception has its arguments in a tuple, and they're stored in a variable called args, and the first entry in args is a description of the error. So again, we will run our program, and I'll enter Brad, and you'll see this is actually a little more informative error, invalid literal for int with base 10 Brad. So it's actually probably a better error message, and often you're just better off printing whatever error message the Python interpreter has provided. Our second example shows several potential errors that are protected by a try block. The first one could be an I/O error associated with opening the file. The second one could be an invalid read of an integer. And then the third one is simply catching an unexpected error, in this case a division by 0. So you can see our first except block catches the I/O error, prints out some information about the error. So in this case, the error has some attributes that we can use. Second case, we're simply going to print out the fact that we couldn't convert the data to an integer. Then in the case of an unexpected error, we're actually going to not be able to bind our variable to the exception object, but this sys.exception info will return a tuple. The first entry, actually the 0th entry, gives us information about the type of the error, and the second argument, which is 1, is going to actually be the error object. So in this case, we would print the type of the error, and then we're going to re-raise the error because we didn't expect it, we can't handle it, so we're going to get out and quit the program. So if we run it, okay, we get no such file or error because I don't yet have the file. Now I create the file by touching it and rerun. Now the file is empty, so I can't convert the data to an integer. It doesn't work when I do my read line. So I add 10 to the file, and now I get the division by 0 error. You can see that up here I printed unexpected error and then the 0th argument. So it printed the type of the error, type exceptions.0division error. And then this traceback comes from raising the error. I did not handle the error. And you can see it printed out some information about it. Y equals 3 divided by 0 was where the error occurred. The error is 0 division error, integer division, or modulo by 0. And our last example is we'll postpone our last example for a moment. So let's just quickly go back and review our try block. So what happens is we first, when we're executing this, we try to execute our protected code. If no exception occurs, then the except clauses are skipped, and we next evaluate the else clause. This is if the try succeeds, and then lastly, we evaluate the finally clause. So 1, 2, and 3. So that's in the case of a success. Okay, now let's handle what happens in case of a failure. So in case of a failure, we first start again with the try block. So first the try block, but now there's an exception. Let's say it's handled. So let's say one of these catches it. So the error handling code is executed. And then we execute the finally block. So that's if the exception is handled. And the final situation occurs when the exception does not get handled. In that case, the try block gets executed, an exception occurs, it's not handled by the except list, so the finally clause, if it exists, is executed, and then execution is thrown up to an outer try block, which will try to handle the exception. Now, it is permissible to write user-defined exceptions, and we will show them in a moment. And again, what you put in the try block is protected code, code that you think could cause an error. And in the else clause, you put the code that you do not expect to cause an error. And if an error occurs, you're willing for that to be thrown to an outer try block. Okay, a few words about the except clause. So first of all, you can use a parenthesized list for the except clause. So I could say runtime error, comma, say type error, and that is going to catch any of those 3 errors. So if you're going to use an except clause and catch multiple errors in the same clause, put them in a parenthesized list with a comma. Also, you already saw how we could bind exceptions. So for example, except value error as E1, and that will let you get access to it. The important thing here is that if you want to print things, then E1.args contains a tuple of the error or of the arguments passed to the exception. Tuple of the args passed to an exception. And args 0, so the first entry, contains a description of the error. Now, generally, you can print some error message, or you might print args 0 to get a nice error message, like in my value error case where I was repeatedly prompting for X. Actually, printing args 0 was probably a good idea. In fact, E1.args 0 was a good idea because we get a nice error message. The third thing is about how exceptions are matched, and it's the same matching as in Java. So exception matching is like Java, which means that the first exception matched is executed. So the first exception matched is the clause executed. Okay, and remaining clauses are ignored. So even if you have another exception occur in the clause that handles it, that will be thrown to a higher try block. It will not be handled by the remaining clauses. So the remaining clauses are ignored. And that means that you should list exceptions from most specific to more general. Otherwise, you may not have an exception get handled in the way you expect. So list exceptions from specific to more general. Hey, as an example, if I had one except list that looked like except exception, which is the base class for all Python exceptions, and then I had another one that said except IO error. Except IO error would never get executed because this one's going to catch all possible exceptions. It's the most general. So the right order would be to put except IO first and then except exception second. And this is another way to catch all exceptions instead of just saying except. If you really wanted to bind, you could say except exception as E, and now you could handle any exception that occurred. And the final thing we're going to talk about is, in fact, raising exceptions. So typically, Python does that for you. So there are the Python exceptions. So Python exceptions are raised automatically. And you can also raise your own exception or raise user-defined exceptions. If you do that, then you should make your user exception. Well, first of all, we'll show us raising one. So let's say we raise, say, wrong args. And we pass as an argument usage foo file name. So what's going to happen is we're passing one argument that will get bundled into the .args, and it will be a tuple with one element, and therefore this first argument should be a nice description of the error. And any further arguments can be additional arguments. Of course, you're also allowed to provide a constructor for wrong args, in which case you could have named arguments. So you can either have unnamed arguments that go into .args, or you could have a constructor that would take a set of arguments and put them into the right place. So if you're going to do this, then you need to make your exception be a subclass of exception. So let's actually show an example. So this is a way that you might handle the wrong number of command line arguments. I've created a class called wrong args, made it a subclass of exception. This is important. If you forget to do it, things won't go the way you expect. I'll show you that in a moment. So if the length of sys.argv is not equal to 3, we raise wrong args, passing as our only argument a description of the error. Otherwise, we print our arguments. So if we run this with no arguments, you see we get wrong args, usage, foo, arg1, arg2, which is what we expect. If we run it with the right number of arguments, well, it should be foo.py, say 3 and 6, it prints 3 and 6. Now let's say that you forgot to make this be a subclass of exception. So let's run it, and you see we actually get this time a type error which says this constructor takes no arguments. And that's right, because we didn't define a constructor, and that's because we didn't define wrong args to be a subclass of exception. Okay, so please remember to declare your exceptions to be a subclass of exception. Now, we could have also defined our own constructor. So we could have put in here like wrong args, say length of sys.argv, so we're entering the number, and we could provide our own constructor. So self.description equals, describe and length. So describe and self dot say args length equals length. And now we could actually try to catch this. So we might say try, and we will do a catch, an accept on wrong args as E. And now we will print wrong number of arguments. Args you entered, and then we'll say E dot args length. So we'll run that. And running this, we now get wrong number of args you entered 1. So in fact, remember with Python, there's always one argument, which is the file name. At any rate, summing up, you should make your exceptions subclass exception. If you want, you can provide your own constructor if you want to name your arguments. If you don't want to name your arguments, don't provide a constructor, in which case you need to provide something. The command pass just says do nothing. And then you can provide as many arguments as you want. And here, instead of now saying e.args length, if I said e.args1, then it also prints out that number. But in this case, it's an unnamed set of arguments, and we'd have to get at them positionally. That concludes our lecture on Python's exceptions.